it's time to start the last session, and session 7. So this session will be chaired by Professor Ballado. And we are behind the schedule around 35 minutes. Please keep the time by yourself. And Ballado, please.
Good afternoon,
Please.
everyone. May I request all the participants to open their camera for. Okay, thank you very much. You may now turn off your webcam and your mic, and then let us listen to the pre-recorded presentation of the 23rd paper, the title of which is a study on applicable and improved k-Cliques method to the recommendation system by Dr. Phonexay, Vilakone.
From National University of Laos. My presentation today is a study on applicable and improved k-Cliques methods to the recommendation system. Here is my content of presentations today. Today, the users in online social media are increasing rapidly. Then the size of the social network community is vast and very intricate. The relationships among the users in this network graph might be beneficial. Classify users from this network graph into the various community is a grand challenge for the multiple researchers. So we develop and improve k-Cliques method to find the sub-community from these networks. Proof that this method is very efficient in the community detection from the various network graph. It is a challenge for my research. As we know, the primary strategies of the business over the internet is a recommendation system, and across things, the number of items has increased to become more concrete. So, to find items that users are looking for through the existing technology of a recommendation system is quite a little bit hard. The most current recommendation system, for example, in YouTube, Netflix, or TikTok, they are using collaborative filtering methods. And here is the methods that's included in the collaborative filtering. But they also have some problems like cornstarch, data sparsity, and scalability when we're using this method. For example, Netflix, they are using viewer rating, viewing history, information about the category, year of release, title, genre, and more. Auto viewer with similar watchings, preference, and tasks. Time durations of the viewer watching a show shows the device on which a viewer is watching, the times of the day a viewer watched. Based on the fundamental knowledge about the user who have the similar feature information, they might write the same item. Therefore, the main motivation are the risings, creates an efficiency network graph from the similarity among user personalized information, find an efficiency methods on community detections in various network graphs. Prove the knowledge of user who has similarity personalized information might write the same item in the recommendation system. Find an algorithm on increasing accuracy in the recommendation system. Here is a related words for related words. The first one is FCA. For the FCA is a techniques of the data analysis that describe the relationship between a particular set of attributes and specific sets of objects. There are two types of outputs, concept practice and attribute implication. How to create the FCA network graph? First, create a formal context from user personalized information training datasets. Then create a concept practice from the formal context. After that, the attribute implication functions or associations rules function used to create a relationship table that's described as the relationships among the user. Finally, a network graph was created from this table. Further next is the k-Cliques. K-Cliques is a technique in the social network analysis used for analyzing data in the complex community. Of the community from the network graph that have a value of k-Cliques. Improve k-Cliques. Develop and improve k-Cliques methods. First, the trading dataset is created from the movie rent dataset. Second, this dataset used to create a network graph. After that, applies k-Cliques to cluster this network graph into a several community by using a value of k equal to 3 to 14. Later on, a suitable community will find new user. Finally, list of 5, 10, and 15 movie from the suitable community will be recommended to a new user. Afterwards, we perform experiment randomly for each dataset. For the proposed methods, we divide into 4 methods. For the first one, we study, develop, and apply a social network analysis methods, network graph methods, detecting a community from the network graph using k-Cliques, develop and improve k-Cliques method, similarity measure methods, collaborative filtering methods. For the second method, we study, develop, and apply a network graph technology, data mining technology, improve algorithm of the purpose work. For the third method, we study, develop, apply on the various like social network analysis, between net century plus KNN, normal discount cumulative gains methods, improving algorithm of the purpose work. And for the last methods, we study, develop, apply on the formal concept analysis methods, creating a network graph based on FCAs and various parallel processing techniques. This is the detail of the method 4. First, we use movie datasets, and then we create a network graph using FCA. After that, we divide into the various community by using k-Cliques and do parallel algorithm. After that, when new user come to the system, the new user will be defined for the suitable community for them. After that, list of recommending moving will be generated by using data mining and do parallel algorithm. After that, the recommended movie to the new user will be generated by using data mining. To find the suitable communities, we use the KNN and between centrality methods. For the evaluation for datasets, we use movie length. And for accuracy measurement method, we use mean absolute percentage errors. And here is the existing method that we use to evaluate our proposed work. Here is the result of each method. For example, result of k-Cliques, result of maximal clicks, result of using collaborative filtering, and the comparisons of the all methods. Here is the result of the method 2, and the result of the proposed works for k-Cliques, and KNN and POCF. Here is the result of method 3 for the proposed method k-Cliques and AR, k-Cliques and CF plus KNN plus NDCG. And here is the result of the last. We can see is when we use to parallel processing, our time that we use for experiment is decreased from 48 hours to 12 hours. Conclusions. The major significant finding, we are the first on develop and apply the various methods. We develop a social network graph from the feature similarity among the user. Apply k-Cliques method to the classified community in the social network graph. Develop improve k-Cliques methods. Applies improve k-Cliques to the recommendation system. Develop a network graph from a formal concept analysis method. Applies an FCA network graph to the recommendation system. Applies the do parallel algorithm to divide the proposed works algorithm into the several processes. then execute them as a parallel processing using the multiple cores Phyu. The results of experiments was improved that and improved k-Cliques was efficient in detecting the commodity from the wireless network graph, very significantly increasing accuracy in the recommendation system, solve a cold start problem. For the feature study, refer to the limitations of the experiments set up. Limitations of the datasets which provide a few feature information of the user and the complexity of the proposed algorithm. In the future, the various time datasets and various feature information of user will be applied to the proposed work. The proposed method algorithm would be modified for easy to apply in real work. My presentation is finished. So for any suggestions, comments, and questions, please do not hesitate to send an email to me. Thank you very much.
Okay, thank you very much. Again, may I request everyone to open your respective cameras. So we'll again take a photo of all the participants prior to the second center for this session. Okay, I am requesting everyone, please. Is it already okay, Sarah?
Yes, okay, sir.
Thank you. Thank you very much. Okay, you can now turn off your webcam and we can proceed to the next center, number 24. The title of the paper is Transfer Learning-Based Object Detection and Classification, to be presented by Ms. Phyu Myint of University of Computer Studies, Yangon, from Myanmar. Okay, you may start your presentation. Please, Ms.
Yes.
Myint, go ahead.
Yes. Hello everyone. I am Phyu Myint from University of Computer Studies, Yangon, Myanmar. Today I would like to present about transfer learning-based object detection and classification. These are the contents of the presentation. I would like to introduce about the presentation. Object detection allows us to identify and locate objects in an image or video. Object classification is a process of predicting a specific category for an object in an image or video. Deep learning is deep learning having yes, sorry. Deep learning technology has hello. Yes. Deep learning technology has been successful in many fields in recent years, including computer vision. Transfer learning is an approach in deep learning and machine learning where knowledge is transferred from one model to another. During the process of transfer learning, 3 points must be considered. The first point is what to transfer. It should be identified that which part of the knowledge can be transferred from the source to the target in order to improve the performance of the target test. The second point is when to transfer. Transfer learning techniques should be utilized only if it makes the target test performance or results to be improved. The third point is how to transfer. After the first and second points are finished, ways of transferring the knowledge across domain or tests can be identified. Of the presentation are to classify objects using transfer learning technique, to detect objects using region proportional network, to view the detection and classification results via web browser, to comparison or transfer learning technique using the proposed data. I would like to tell about motivation of the presentation. Fast and accurate object detection classification systems are rising in demand. Traditional feature extraction techniques mix and hand clutter to extract features from the image. Deep learning technique requires a very large amount of data set. Obtaining large data sets, this has been made time consuming. Training is very expensive, pulling time and resources in order to get large and effective deep learning models. This figure shows the overview of the system. The dataset is collected by using Phyu support IP camera. Transparent technique is used to obtain the customized model in order to detect and classify objects in the proposed dataset. The obtained customized model is deployed to Raspberry Pi. The resultant frame or the test image can be seen by our web browser using the +1 framework. The proposed dataset contains 3,000 images. The dataset is split into training, validation, and testing dataset, which contain 1,920 images, 600 images, and 480 images respectively. The categories of class are as follows. I would like to share about transparent learning. One of the most well-known transparent learning technique is fine-tuning. The first issue for using fine-tuning is that trained models are only partially transferred by discarding test-specific layers and fine-tuning bottom layers. The second issue is that by placing weights in lower convolution layers and retraining weights in upper layers using data from the target domain, parameters of the target model may be driven far away from initial value, which also causes overfitting. In order to solve the first issue of fine-tuning technique, fine-tuning is used. Suppose that S0 is a bitrate deep neural network, YS is a source category, and YD is a target level to length category relationship. The mapping YS to YD is firstly learned from F0 or HD, YD best, where F0 or H is approximately equal to probability of YS given A is a probability distribution over YS. Probability of YS given YD can be computed from probability of YD given YS by base rule. To be reflected with high fidelity of the probability output also categories of F0 or H category relationship learning mentions a calibration procedure. This table shows the category relationship between host dataset classes and ImageNet dataset classes. For example, class in proposed dataset is highly relationship with moving type class in ImageNet dataset. To solve the second issue of fine-tuning technique, behavior-based regularization using feature-based attention is used. Behavioral regularization is that the distance between the network behavior is considered to regularize the behavior of the networks. Feature-based extraction from convolution layer is that each feature of the network from the target dataset is used to get the corresponding output. A weighted feature matched with supervised attention model is that the weights of features are characterized by the potential performance loss when removing these features from the network. In order to locate the objects, region proposal network is used. To generate region proposal, each small network is slide over the convolutional feature map output and the larger convolutional layer. Multiple region proposal code and class are simultaneously predicted at each slide developed location. The region proposal network is trained for the region proposal test. The Flash web framework is used in order to use the resultant training web browser. Flash is a popular micro web framework written in the Python programming language. Flash is very lightweight, making it super easy to build easy web applications. These figures are the sample resultant frames. In order to evaluate the performance of the customized model based on the classification accuracy. And the proposed dataset is trained by using the hyperparameters such as learning rate is 0.001, momentum is 0.9, weight decay is 0.0005, and number of approach is 100. According to this table, conditioning technique and behavior-based regularization techniques are more accurate in classifying objects than fine-tuning techniques. In conclusion, this study is implemented using transparent technique and pre-trained Raspberry 50 model based on image data set. It's used to generate the customized model. A customized model can be built by using transparent even if there is a small data set. It also may us to save training time. The process information can also be viewed by our web browser. These are the references of this presentation. Thank you for your attention.
Professor Ballado, we can never hear you. Professor Ballado, we cannot hear anything from you.
Hello?
Your mic is set to off.
Oh, yes.
No, sorry. Professor Ballard's mic is set to off.
Yes, yes, no. Hello? Can you hear me?
Yeah, they can hear you.
Sorry, the chair of this session has his microphone turned off. My apologies. Professor Ballard? If anybody has any questions for the presenter, please feel free to ask them now.
Okay, yeah, maybe I can ask something. It's not really a question, but maybe what kind of environment you are looking for? What type of application you are looking for in this? What in your mind when you plan to do this at detection of car people, and what is the need for that detection? What do you use it for?
Yes, yes. As the objective for this system is to use in campus monitoring system.
Right. So you want to detect people and car like that, right?
Yes.
And pass. So I would assume that the Wi-Fi signal should be good. Can we assume that? Can we assume that the connection, the Wi-Fi will be good? Because I think, okay, my point is that I think the design of the process and the hardware and the software depend a lot on what you want to get at the end. Like if it's going to be put at the edge where there is no Wi-Fi, that means you need to have better to have the model inside, right? Or if it has the Wi-Fi, maybe one option would be you actually get and then send over the internet to retrieve a very high quality prediction. The design decision like that. So I think if you are clear on what actually to get, you actually can design the process in more detail, and you can be more like precise on what you want. Just the idea. You're doing, yeah. Thank you. Very good presentation. Thank you.
Thank you, sir, for your suggestion, and thank you to the National Institute of Information and Communication Technology for supporting the camera and Raspberry Pi transmitter.
Thank you. Is there some question from audience? Not anymore? Thank you. And may I ask you one? So what kind of the application are you trying to develop? What kind of the application? Can you hear me? Mr. A. for Myint?
Yeah. Hello.
Yes. Can you hear me?
Yes, yes, sir. I can hear you.
So may I ask you one question? So what kind of application do
Kind
you plan?
Yes. Yes, 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 my application is a campus monitoring system. Yes.
You mean the traffic monitoring? It's
Yes.
okay?
Yes.
Thank you.
Yes.
Thank you very much. And is there any other questions or comments? Okay, thank you very much, Mr. I'm sorry, Myint. So let me move to next presentation. Next presentation will be presented by Mr. Ramon Vann Cleff, Bornales, and of the DOST-ASTI from Philippines. Can you hear me?
Yes, sir, I can hear you clearly.
Okay, please.
Thank you for the introduction. So hello, everyone. Good afternoon. I am Ramon Van Cleff Raro from the Department of Science and Technology, Advanced Science and Technology Institute, DOST-ASTI of the Republic of the Philippines. And I'm here to present to you our preliminary work regarding the topic, LoRa-Based Mesh Network for Off-Grid SMS-Style Communication in Emergency Situations. So to start, let me talk to you about the background of this project, on the motivations and the rationale on why we thought of this project. So there would be instances where our conventional communication networks may be incapacitated, could be damaged.
We didn't see your slide yet. Did you share?
Sorry. Let me share the slide. Sorry for that. There. So once again, let me introduce you to the project entitled LoRa-Based Mesh Network for Off-Grid SMS-Style Communication in Emergency Situations. But to give you an introduction to the rationale of this project, so there would be time when conventional communication networks could be incapacitated, unavailable, or damaged. And this could be for a number of reasons. One is natural disasters, and as we all know from the ASEAN nations, we are plagued with many natural disasters all throughout the year. So there could be also technical failures from time to time, and also the possibility of warfare where our infrastructure could be damaged. So at these times, data is very crucial for, first of all, situational analysis, to see the situation on the ground. And then once we see the situation on the ground, it's good for the next step, which would be strategic planning. And then when a plan is cooked up, then we can plan for search and rescue operations. But also, this data is important for general communications. So the proposed solution for this kind of instances is an off-grid SMS-style communication network based on low-power wide area networks, or LP1. So let me talk to you about the relevant technologies of this project. First, this project utilizes Lora Technology, which stands for long-range radio networks. So this technology is based on a mesh network, and we use this because of its low power. This can be powered off-grid through solar panels or battery. It has long range and can serve as relay as well as a node. And because of the frequency of operation, which is naturally unlicensed and it's in the ISM band, so it is free to use. So now, why did we use or choose SMS-style communication? So this actually stems from the Lora technology limitations, particularly on the data rate. As we all know, the data rate of LoRa communication is very low. And so we also chose SMS-style communication because it is simple enough to convey crucial information, like the situation, location, or if someone needs help. So there have been relevant previous works by ASEAN IVO members. The first one is a relay station network based on low power wide area network, LP1 technologies, for disaster management. So this uses LoRa nodes as a relay for communicating sensor data and throw this data into the next relay until it reaches a base station, which can send it to the internet and to the Center for Data Analysis and Preparation. So the second one is a LoRa-based mesh network for off-grid emergency communications, which uses an ESP32 microcontroller plus LoRa module and connects phone via Bluetooth low energy to provide an SMS-Style communication. Now, the current implementation we want to do in this project is we want to use the Wi-Fi access point of an ESP32 microcontroller versus Bluetooth cost of its longer range compared to Bluetooth, its higher data rate compared to Bluetooth, and better capacity for multiple users. Remember that we are planning to a mesh network configuration. So the configuration for LoRa is an ESP32 microcontroller and RM95 configuration. It can function as a. For this project, we use a LoRa messenger. And using the application, you can configure the frequency of operation, the spreading factor. You can also set the transmitter power. You can set your node name to set as your identity. You can also set your recipient, whether it be another node or a broadcast, and other parameters for SMS-Style communications. So nearby active nodes are discoverable with our SSI and possible number of hops to reach. So we know how many hops it took for a message to receive, for the receiver to receive our message. So it's also easy to use because of its intuitive chat box interface. So we were able to do some lab testing or node setup in ASTI, where we were able to set up an off-grid capability setup, wherein it consists of an ESP32 and RFM95 LoRa module, powered by a photovoltaic source with MPPT solar charger and battery placed inside an enclosure box and mounted on a pole. So as you can see on the image on the right, that's the setup. So our lab test consisted of testing capability for phone connection to the LoRa node via the Wi-Fi access point of the ESP32 microcontroller. And we, for node 3, wanted to know which nodes were active and in the area, the setting of node name, our identity as the source or sender, and the recipient, in which we can set the recipient, or if we want to broadcast the message to active nodes in the area. And then we were able also to test the basic send receive functions and the power supply of the setup. So the tests done to test capabilities were in an urban setting using 23 dBm transmit power, a spreading factor of 7, which means a higher data rate. We also operated at the frequency of 868 megahertz LoRa band frequency. So let's now talk about some field testing that we were able to do. So we were also able to do some preliminary field testing, although limited. And we were able to conduct the same tests, but were performed on a rural setting in a province in the Philippines where no connectivity is present. Because remember, one of the aims or one of the objectives of this project is to provide a temporary solution for communications. And we set the setup to have a 23 dBm transmit power, a spreading factor of 7, and operating at 868 megahertz LoRa band frequency. To keep mobility easier, instead of using photovoltaic setups, we used power banks instead in place of photovoltaic power supply, so we can move around the area. Our preliminary observations were that as the number of characters successfully sent to a receiver decreases as node-to-node distance increases. So the setup here is we have spreading factor of 7, and we were testing it at a node-to-node setup. And we also were able to notice that foliage seems to have great effect on the send and receive success of the setup. And we were able to infer that maybe a mesh configuration may help with issues. Because basically you're increasing your node participation. So we have our future plans for this work where we want to explore tests using a mesh configuration, as you can see in the figure in the right. So one node may be connected to multiple users using their mobile phones, and then each node will be connected by a LoRa link. And these nodes will be connected in a mesh setup. So we also plan to study the routing algorithm used and explore optimizations or an implementation of a new algorithm altogether for the optimization for this type of application. So we also want to test we will also want to conduct a stress test on the operation of both node-to-node and mesh operation on power, how long it will last, environmental conditions, how long it will last in a rainy environment, in a very sunny environment like that. And we also want to see the packet data rate, or basically the amount of success of sends or receives as the number of nodes increases or the number of users per node increases. And also we have there is a potential work to create a personalized version of these LoRa nodes, similar to open source projects like Mesh-ASTI and Disaster Radio, wherein instead of a LoRa node that is stationary in one area, each person can carry a personalized LoRa node, which can function as a personal emergency communication device. So we also plan to involve incorporation of other essential modules like GPS to include location. And this might be essential for applications like rescue operations in times of disaster. So as you can see on the figure on the right, there are that's the example of personalized LoRa nodes, which can be used for emergency personal communications. So that's the end of my presentation. Thank you for listening, and I now open the floor for any questions. Thank you.
Thank you very much for your presentation. Are there any questions or comments from audience? Any
Hello.
question and the comments? Yes.
Can I ask a question?
Yes, please.
Okay. So, Ramon, right?
Yes, sir.
Ramon, I just want to ask. So you are using LoRa Mesh network. What is the user interface? I mean, what do you use? For example, smartphone or computer or what?
Yes, sir. The process is that a user can connect to the LoRa node using the Wi-Fi access point of the ESP32 microcontroller. So you can use your mobile phone, your laptop, or your tablet as long as it has a Wi-Fi capability. And the user interface is an open source messenger app, it is browser based. So it's not Android, but it's browser based. So basically, when you connect to the LoRa node via Wi-Fi, the process is that it gives you a similar to a sign-in
SMS.
page. Yeah, sign-in page wherein when you access that page, it will guide you to the interface, to the chat box interface.
Okay. Okay. Following the question, just another question. You know that LoRa network is not that often existing in the areas, right? So how useful is actually this project? I mean, if there is no LoRa mesh network, then this project is cannot be used, right?
I respectfully disagree a bit with that, sir, because
Okay.
we could think of an individual LoRa node as, for a lack of better term, a base station itself, wherein multiple nodes could connect to it and connect to other nodes as well. What my point here is that we can use this for localized operations, like for
All right.
example, a city coordination wherein there could be disasters in an area and there's the network is down, or maybe there's no
Mhm.
network at all, no conventional network at all. The government, local government units could use these devices to communicate with, for example, people on the ground, which are able to assess the situation. So this could be used locally, but
Okay.
yes, sir. But we could also scale as well.
How fast you can install LoRa network, and how much is the cost
For the
for your
cost,
project?
actually, sir, if we were to establish a single node with the photovoltaic supply,
Mhm.
it may estimately cost around $500.
All right.
But
Yes.
the LoRa node itself, if you were to buy an ESP32 microcontroller, LoRa module, and an antenna, it would only cost around $260.
Oh, okay. Okay. That's fine. Okay. Thank you. Thank you. Thank
Thank
you.
you, sir.
Thank you. Is there any question else? So may I ask you one? And I think you know the project relay station led by Nectec Thailand. So what's the difference between you talk and this project?
Yes, sir. Actually, that project is one of the relevant previous works where this work is sort of a related literature, if you must say that. The difference is that in that project, each node is functions only as a relay in which the information from sensors are passed to each node until it reaches the base station, from which that information, the sensor information, could be distributed to necessary parties. But in this work, our goal finally is to actually create a personalized version of it, and not a stationary node where people will have difficulty to connect to for this purpose.
Thank you. So a simple one more. So what kind of the emergency situation are you considering?
Sir, I think the most possible cost for this is maybe earthquake, or maybe a landslide wherein maybe a cell tower is situated somewhere that may be damaged. So the floor might be damaged or the earth might be damaged.
Thank you. Thank you very much. And I need to move to next presentation. Thank you. So let's move to next one, the last one. This presentation will be presented by Mr. Thayheng Nhem from the Cambodia Academy of Digital Technology. And the title is the design and development of a certificable real-time IoT solution. Can you hear me?
Thank you. Yep, thank you, sir. Thank you very much for your introduction. I will share my slide right now. Hello, everyone. I'm sorry, I know I will be the last one, so it's a bit of time thing. So I will be as quick as possible. So I know it has been a very interesting morning regarding the topic about IoT and stuff, and it's really related to my work. But
I'm sorry, please show us your presentation whole screen.
Oh, sorry.
Yes, okay.
Is it better? Okay, so yeah, so there has been a talk a lot about regarding using IoT and different sensoring and stuff in the different field of agriculture and thing, and it very related to the work I have been doing regarding the network protocol in for using in IoT. So my topic is regarding building the real-time network protocol for IoT. So today I have 7 small parts. I will introduce a little bit about the problem, why we build this project and the objective we want to achieve, the technology we use, and the function that I develop in order to get what we want, and the deployment setting to test if our developed function is working. And then we're looking at the deployment result, how does it turn out, and that will be following up regarding a small conclusion of the experiment. So the problem is that if you are aware of the current 60 protocol is one of the protocol using in IoT network, and this protocol is not deterministic by its own, because this protocol stack involve different protocol that is not it's not time sensitive. That's why real time is not possible in this protocol. Plus the tree, as you can see in this picture, is that node is working and communicate with each other in the tree pattern. This, you can see, will increase more time in terms of transmission delay from one node to another. Like in case if you want to transmit from node D to the root node or the coordinator or access point, as if you like, it will have to go through its parent node, and then the parent node go to the root node. So it will have a bigger latency in terms of transmission. So that is the problem we want to address. And the other problem is that in the 60 protocol stack, there is a protocol that involved in this communication is 6-top. So 6-top is a protocol to conduct a communication link between node and node. And in this protocol, node have to request if they want to send the data or something, and then the root node or access node have to confirm if the node can do the transmission or not, and that communication has to go on and on. That's why we cannot determine whether the transmission is being concluded or not. So that is also the part where we will address as well. So coming from the problem, the objective that we want to build is we want to build a solution, a network solution, where node can transmit to any node in the network. If you can see here, from node A can transmit to node B can transmit to node C, and node C can transmit to node A back or whatever, meaning any node can send the data to each other without going through the routing protocol or any other protocol. So that is what we want to build, and we want to make sure it's transmitting in a timely manner. In order to achieve the goal, the technology we use is the introducing to Contiki-NG. So Contiki-NG is one of the popular open source operating system that I think that is being used right now in the field of IoT, and the important that we are going to use this technology because it is built in with the wireless communication protocols such as TAST and more. So it's a standard open source operating system. So so in this part we will use this Contiki-NG operating system to build our solution that we have TISH protocol available in them. So we're going to justify the the protocol and make them use in our to serve our goal. So a little bit of introduction into TISH communication protocol. So TISH is like you can say a big part of 6 TISH because it's like the main protocol that the node can communicate with each other. In this protocol, they use a wireless means. So there is different channels you can use, and then the time is divided into a small slot that is normally 10 milliseconds, if you can see here. And then that slot is being captured into a super frame or slot frame with 150, 200, depending on our configuration. So that is some characteristic of TISH. And with that, with what we have, we want to build this function in order to serve our goal. So the first one is that we want to eliminate 6 top protocol in the 6 TISH, so that the node, they don't have to communicate back and forth in order to be able to transmit or send the data. And we also want to eliminate the routing protocol in the network, so that you don't have to go in terms of 3 pattern in order to communicate. So you can just do a direct communication with all the nodes in the network. So to do so, we eliminate the 2 protocol, and then we create a new type of message. We call it command message. In order, this command message is purpose to its purpose is to handle the data transmission from the root node to tell the node that in the network what time they can communicate, and from which from what node to what node on different channel and stuff. So that is the configuration that we have to do, so the root node can send to the normal node. And the next function is we want each node to handle and listen to command message, because earlier in the 60 protocol there is the node only they don't handle the command message, they just listen and communicate with the 6 top protocol. And then the other one is node has to be able to handle the data message when another node send the message to themselves. So after the development of the function, we deployed, we do the experiment, and you can see the experiment here. This is the configuration we put. So in the first slot, the root node will send the enhanced beacon. It's like the opening of the network. So each node listen to the enhanced beacon and join the network. After that, root node send the command message 1 and 2 in the slot 1 and 2, so that all nodes listen to the command message and understand it, so they know when they send or when they have to receive. So it will reduce that they don't have to use, we don't have to use 6 top protocol. That's where it's working out. So after this is the deployment setting, and then here is the proof of the development. When we already deployed to our device, we listen to the transmission through Wireshark, and then the result is the proof that the develop function is working, and our node can communicate with each other in a timely manner, and there is no the transmission delay is not there anymore. And after the deployment, we go on further to study the determinism of the network. So with that, we have to study the jitter and everything in order to understand the transmission delay in the node. And then we see the experiment. It's look like there is a pattern that in every 4 transmission, meaning every 4 super frame, there is 1 transmission that is happening to be very late, and it's happened at the same again and again. So with that, we can conclude that in every 2 seconds, it's possible that the root node is doing the update of the network time, so that every node is being synchronized. That's why we have a latency in the first transmission. So that is the end of my presentation. Thank you very much. And if there is any project that may be possible that we can work together in IoT, it's a very nice that we can collaborate with each other. Thank you very much.
Thank you for your presentation. And I would like to ask any question and or comments from audience.
Yes, please.
So any question or comments? So may I ask you one?
Yeah.
Yes,
I
please.
would be interested to know more about this network and your project. Please contact me if you can, or if you can give me your email. Also, Ramon, the presenter before, Mr. Ramon, if you could give me your email, I would be interested to communicate with you too. All right? Is this okay?
Thank you very much, sir. Yep, I will send you my email then.
Oh, yeah. Okay. Thank you very much.
Yep. Thank you, sir.
Any question or comments else? So may I ask you one? Okay. So you proposed your new protocol. So are you trying to do some field trial with some company or vendor like Cambodian Telecom with a big scale?
No, sir. Actually, it seemed like a new protocol. It's just like an add-on on the TISH protocol that already exists. But and regarding the deployment, we only deploy in our own setting. We haven't reached out to the industry regarding the testing of our protocol yet. But it's working out very well in our environment.
Thank you. Something else? Okay, thank you very much for your presentation. So let me conclude this this session, and thank you for the 4 speakers for their presentation. I would like to close this session, last session, session number 7.